So good morning. Once again, I welcome into the same session from where we stopped, which focuses on the classification of the instrument, that is absolute instrument and the secondary instruments. So if we can revise the things, the absolute instrument gives the value of the electrical quantity to be measured in terms of the constant of the instrument and its deflection. So that is no comparison with another instrument is required. We have taken an example of tangent galvanometer. As far as secondary instruments are concerned, they are constructed that the value of the measured quantity, such as current, voltage or any other quantity, can be determined from the deflection of the instrument only if the latter has been calibrated by comparison with either an absolute instrument or one which is already calibrated. I have also shared an example of how to be calibrate or how to be calibrated the instrument. The deflection is obtained is meaningless until such calibration has been made. So moving further, in case of secondary instrument, we are having three instruments or three category of the instrument. First is the indicating instrument. The name itself indicates that, which are indicate the magnitude of the quantity to be measured. They are generally make a use of dial and a pointer to indicate the quantity for this purpose. The second category is the integrating instrument. The integrating instrument are used to record the totalized event over a specific period of time. The summation or a summer which they give is the product of the time and electrical quantity. The energy meter or watt hour meter or ampere hour meters are the example of integrating instrument. Suppose we have consumed 50 watt of power for 5 hours. So 50 into 5 is 250 watt hour is consumed, is a basic example of how the integrating instruments are working. The next category, which is a subcategory of secondary instrument, which are recording instruments. The name itself indicates that it will record. You will find recording instrument everywhere in the physical world. So the recording instrument give a continuous record of the quantity being measured over a specific period of time. The variation of the quantity being measured are recorded by, in case of analog instrument, a pen attached to a moving system of the instrument. The moving system is operated by quantity being measured, or that pen is going to move on a sheet of paper that moves perpendicularly to the movement of the pen, which is also known as the recording instrument. However, by having different primary and secondary instrument, the third category is the recording instrument. Moving further, the indicating instrument. The indicating instruments are those which indicate the magnitude of the electrical quantity at the time when it is being measured. For example, wattmeter. The indicators are given by a pointer moving over a calibrated, that is pre-graduated scale. For example, calibration of the wattmeters. That's what we have done. Another examples of indicating instruments are ordinary analog ammeters, voltmeters, wattmeters, frequency meters, power factor meters, etc. fall into this category. The next is integrating instrument. as explained that there are those instruments which measure the total amount of either quantity of electricity, that is ampere hour, or energy supplied, that is watt hour, over a period of time. The summation of such instrument is the product of time and electrical quantity under measurement. The AH meters and WH meters fall in this class of instruments. The next category is the recording instrument. The instruments are those which keep a continuous record of the variation of magnitude of an electrical quantity or any other to be observed over a definite period of time. The moving system carries, as I told you, an ink pen which touches lightly a sheet of the paper prepped over the drum, moving with uniform slow motion in the direction. That direction is perpendicular to the direction of pointer. Such instruments are generally used in powerhouse where current, voltage, power, etc. are to be maintained within the certain acceptable limit, and this recording instrument, the records are continuously improving. The next category is what we call as a analog instruments. As far as analog instruments are concerned, we are having two different instruments. The first is the direct measuring instrument. In case of analog instrument, the photograph of analog voltmeter is shown over here. By having suitable precaution, if we need to measure the 230 volt or input supply voltage of single phase system, we need to insert the two terminals of voltmeter by keeping the main switch off. After having a suitable connection, you may check it whether that connection is not loose, then turn on the switch, the pointer will deflect and you will get the measured quantity. The second is the comparison instrument. The measuring quantity is compared with the standard instrument, is known as the comparison instrument. It also needs the calibration. The comparison instrument are the instrument which has to be compared with the direct measuring instrument. In engineering discipline, usually the direct measuring instruments are used. So let's have a quick look on one of the video where these instruments have been used. In this case, this is the non-calibrated analog voltmeter. That guy has been calibrated. Stop the calibration when the pointer reaches at 0. Then a small DC power supply of 30 volt 5 ampere has been turned on, and see how the voltage has been measured. Now we need to do a lots of periodic check. The first check is, see the supply. See the supply, it is of 30 volt 5 ampere. So we need to take at least 30 volt range. This is known as the range. It means that we will not measure the voltage which is more than 30 volt from this. So this is what about the analog instrument. Now another category of instruments are indicating instrument. For that we need to go for this configuration of pointer, and we need to take care of these three forces on the pointer, because these instruments are known as electromechanical. With the motion of electrons, the mechanical movement in the instrument will be occur. That is what we call as the electromechanical instruments. So these three torques are deflecting torque or a deflecting force, controlling torque or controlling force, and damping torque or damping force. The first is the deflecting torque. Any instrument deflection is found by total effect of deflection or deflecting torque, control torque, and damping torque. So the deflecting torque value is independent in certain way, but the deflection is depending upon the electrical signal to be measured. This torque or a force helps in the rotating instrument movement from its zero position. The system producing the deflection torque is called the deflecting system. The second is known as the controlling force or a controlling torque. The act of the torque or a force is opposite to the deflection torque or a force. For example, in that video, if we need to measure 25 volt, then the torque has to be controlled in such a way that at 25 volt the pointer should stop. So when the deflecting torque and controlling torques are equal in magnitude, then the movement will be definite position or in the equilibrium. The spring or a spiral spring is usually given to produce the controlling torque. The system which produces the controlling torque is called the controlling system. The functions of the systems are: the first function to produce the torque which is equal and opposite to the deflecting torque at the final steady position of the pointer in order to make the deflection of the pointer for definite for a particular magnitude of the current. And the second one, to bring the moving system back to the zero position when the force causing the instrument moving system to deflection is removed. It means that whenever we will remove the supply, again your meter should indicate 0. So the deflecting torque is the torque which helps in rotating the instrument from its zero position. Controlling torque which produces the controlling torque in the control system. Damping torque, most important thing. As far as damping torque is concerned, it is generally works in an opposite direction of the movement system. For example, there are different damping systems are available: air friction damping, fluid friction damping. The most important and very much used in the market or a practical world are the eddy current dampings. So eddy current is not a new word for engineering students. So this damping torque through this medium provide the damping torque or force that is to be act. It must also be noted that not all damping force affects the steady state deflection caused by the given deflecting force or a torque. When deflecting torque, which is much greater than the controlling torque, then system is known as underdamped. So there are three damping systems: underdamped, critically damped, or overdamped. So if the deflecting torque is equals to controlling torque, it is known as the critically damped. When deflecting torque is much less than the controlling torque, then the system is in overdamped condition. So this is what the response of the system, and with respect to deflection, the damping will be there. However, the straight line in the left hand side figure with dotted line and then full line are the steady deflection, that is what we are expecting, and in the right hand side figure of the viewer, there is a sky blue line which shows the steady state deflection. So in the description of the various type of instrument, the detailed mathematical expressions are required for the damping torques are taken into the consideration. So, there are various type of system, that is underdamped, overdamped and the critically damped. That systems are there to controlling the torque, and damping is the, we need to stop the system as and when needed as per our choice. So, the first is the damping system. So, there are three damping systems are there: air friction damping, fluid friction damping and the eddy current damping. In case of the air friction damping, what we have is, if the position of the outer pointer or the moving chamber is usually what happens, it works on the basic principle of pressure or a pressure difference. The pressure in the closed surface will fall and the pressure in the open side will be more. So, the motion is thus again opposed and the pointer will deflect on the scale. So, let us have a quick look on the video of damping, that is air friction damping for moving iron instrument, and we are checking the air friction damping. See, check how the torque has been initiated by applying the various quantities to the meter. How the pressure difference will occur. This is 500 watt lamp load. The pointer has been started with the oscillation and it will be stopped when the system comes under the steady state condition with this air damping system or air friction air damping system. Now, when the anti-friction chamber is closed, let's see what happens. Same way, instead of air, if you can have a damping oil inside the same where the instrument spindle is connected, so this oil will create the damping effect. The same phenomena is there for the fluid friction damping. and very important, which is used almost everywhere in the industries, are the eddy current damping. So you know that when the sheet of the conducting material or a magnetic material moves in the magnetic field, so it will cut the lines of force, and the eddy current are set up in the material itself, known as the eddy current effect. We are using that eddy current effect, which is always in the direction of opposition of the motion. The force, which is proportional to the magnitude of the current and to the strength of the field. The magnitude of the current is proportional to the velocity of the instrument of the conductor, and thus if the magnetic field will be constant, the damping force is proportional to the velocity of the moving system and is 0 when there is no movement of the system. For example, if that is the rotating disk of any meter, when it comes under the damping magnet, the force will be opposite of the physical rotating force of the disk, and the vibrations are damped out and the oscillations are damped, and this pointer will provide the steady state value of the damping. So this is what about the eddy current damping. So with this, I am very much thankful for attending this short 2 sessions of Introduction to Electrical Engineering and Instrumentation, types of instrument, types of torque, and types of damping. Thank you very much. Have a nice day. Take care. Stay safe.